Nikita will take us through a short presentation that she has prepared.
Thanks, Winnie. So first of all, thanks everyone for registering for our challenge and also joining the webinar here. So I would like to, introduce myself briefly. So what does EnergyBright do and all of that? So basically, EnergyBright is a energy assessment company. So we actually want to introduce AI into energy assessments so that it makes life easier for energy assessors. So while I was thinking about, what kind of topic that I could bring on to the table for this webinar, I thought, okay, why can't we bring in a topic which is technology for good, and how can data and AI be helpful for achieving the world's target of 2030? So as part of this, so what we're trying to do is basically, we know that there's a climate challenge, right? So with more of AI, with more of data, we are requiring more servers out there. It's also contributing to climate changes. And when it comes to our buildings, almost 40% of your global energy is actually emitted by the buildings. So it's very important for buildings to get retrofit so that the house actually becomes better. So you pay less bills. So if you're paying less bills, that means that your house is using less energy. So traditionally what happens is in Europe and US, there's a process called building energy rating assessment. So the assessor would come home, they'll take the measurements of your house, they'll take your measurements of your windows, doors, etc. And then what they'll do is they'll check your heating system, they'll check if you have solar panels and things like that. And based upon that, all the calculations are made. So currently this is very traditional assessment method, which is very manual, and it is very slow and resource intensive. So that's when myself being a BR assessor, I thought, okay, why not we bring in technology here with my background in artificial intelligence? So we can actually use data and AI basically to transform how we access and prioritize the improvisation of building performances across. So I was actually talking about Ireland as such, because there is a lot of knowledge that I get from Ireland, as EnergyBright is from Ireland. So basically what we're trying to do is we are trying to actually do data analytics kind of thing as well, which can actually help us reduce emissions. So what we do as part of this is we try to find the patterns on, what kind of energy does different buildings actually consume, what is the age of the building, what is the location of it, and how can we smartly prioritize identifying, high emitting buildings and retrofit it. And based upon our retrofitting, there's again something called post-works BR, which actually says, okay, your house was B-rated house, and now it has become an A-rated house. So basically, there is a rating in BRs, which is from A to G. So G being the worst and A being the best. So we can track those as well after the improvements are made using BR assessment, because you'll have a prior pre-works BR assessment and post-works BR assessment as well to understand how better it has become. So what can we do, right? So we have the raw data sitting there, which can be your BR certs, it can be your utility bills, it can be the building registrations, or it can be any sort of that form of data. And also we have unstructured data like site photographs, like we have heritage buildings, for example. We don't need to do BR assessments for heritage buildings, but I'm just giving you an example there. So we have old buildings which are there, which was actually a church earlier, but now became an office. So for that, you would actually require an energy assessment. So you would actually have those site photographs and things like that as well, so that, that would actually help you to extract the insights with AI to say, okay, this is an old building, this would definitely require retrofitting. And then we can combine all the structured and unstructured data to make it a complete picture, to enable things faster and come up with the best decision on how we can scale the energy accuracies. So then how would we do this, right? So we have the data, we have the structured, unstructured data and things like that. So what we do is we use machine learning models that can actually estimate the energy usage based upon the predicted heat loss and what can be the forecasted impact of this retrofitting. For example, let's say that a house actually has a heating system which only has a switch to turn it on. So if the switch is on, the heating system will run. And if the switch is off, it doesn't run. So, but let's say that there is a simple thing, which is your thermostats and your timer that is there. So you don't need to switch on and off, because we might tend up forgetting things and we might just leave it and go when we are going out or things like that, right? So if you already have a thermostat, when the building heat or the heat inside the building, which is 20 degrees centigrade, let's say, it automatically turns off the system. So these kind of small retrofittings can make a huge difference for a building. So what we can do with machine learning is to estimate the energy usages using the machine learning models, and then we can actually simulate the interpretation by saying, okay, now I have retrofitted with an insulation material, or I have replaced my windows, or like I said, I have installed a thermostat. And then what actually happens? We can actually predict the outcome of it, and we will also know what would be the cost savings and what would be the emission that is being reduced, basically the potential carbon emission that has been reduced. And these would actually guide us on the decisions. Let's say if a person wanted only to spend 500 euros, for example. So we can actually put that as a feature as well, to say that when you're actually predicting something for us, they only can spend this much, and we need to give an effective decision based upon the spending capability of the individual as well. So real world impact. So we can actually, when we are trying to optimize using our challenge, where we are going to try and have the VR assessments. So when I go into an on-site, right? So what I do is I just go in and take the measurements myself, or, we have an assessor who would take the measurements. They would go check the heating system, take the photographs of it. But let's say we have a smart system in place, which is AI oriented, and you just come in and you just have to, probably take a picture of the room or the window, and it just gives you the measurements for the same. It makes it faster, right? So that is where we are actually trying to bring in the challenge as well, which would make it faster in bringing up the current VR assessment for the house. And that those information can also be used for the use case that I was talking about, where we would be using it for retrofitting and things like that. It would not only increase the assessment time, basically from, let's say, it takes around 4 to 6 weeks currently, it can reduce drastically to 1 week at least. But the goal for us is to if the assessor come on site, you just have to get over at the spot itself. That would be the main goal for us. So it would definitely reduce 40% of cost, because they actually would target on retrofitting investments that would actually minimize the waste and also maximize the impact per euros that they are spending. And not only that, if an assessor is actually quickly finishing up things, they would be able to take on board on more jobs, and that would also in turn, have a reduced cost for the VR assessment. And because we're going to make it AI assisted, it would reduce the human error, improving the consistency across all the evaluations that we do. So while we come to the challenge, right, how can we actually use AI and computer vision for automating the building measurements? Like I said, you could use OpenCV for reading your images, and then once we have those, those values can be put on into the respective portal for each of the countries that they have. So basically, how does it work? So you're capturing the images, and then AI is actually detecting basically what is the type of, or what is the area of the walls, windows, doors, etc. And then it converts those measurements using your auto measurement tool, and then this would be populated into simulations. It can be populated into simulations, or it can be populated into your SES portal, whatever works for you. Your SES portal is basically for Ireland, but there are different other portals for different other countries. So, like I said, the benefits are the speed, the accuracy, and there's also a safety factor involved, because it reduces the physical kind of inspections in difficult areas. Like when you actually go into a boiler room or something, sometimes you would have so many things that, you have to remove them and things like that. But if it's an image that is actually going to read what is the storage system there, that would make your lives even easier as such. So we can actually scale it across buildings globally. So that's, again, a good feature that we could bring in. So the future of hybrid assessment model, basically, it's the hybrid approach would be the best for, making it easier to initially handle the surveys, monitoring it. I don't think that we would get onto virtual surveys yet, just because there are strict regulations that the assessor has to go on field, but maybe the future can bring in even virtual assessments. Like you could actually ask the homeowners to take those pictures and send it to you, just ensuring their privacy and things like that as well. So the remote first, the digital captures and AI would be actually used, like we said, and we're going to target visits. And then later on, we would be optimizing the results for faster and more effective ways of assessment and maintaining the accuracy and compliances. Yeah, so our vision is basically to have a smarter and greener place, which is basically to meet the sustainable goals of 2030, ensuring that we have 51% of emission reduction goal with respect to Ireland alone. So when we actually take it globally, it's more than 40% that they want. They get energy emissions only from buildings. So, and also there's a lot of career opportunities with the sustainability goals and data science and energy kind of roles that are coming in place. And probably by embracing this digital transformation in Ireland to begin with, can make it a model for greener digital infrastructures across Europe and world as well. So yeah, so when I say about technology, if we use the technology in a specific way, it would definitely create an impact. And the tools actually exist for fewer in the market where the knowledge is actually growing. We have so many Gen AI tools or many kind of packages and things like that are coming across, where you can use your Python in your laptop and try using your prompt engineering to come up with different approaches. So using this technology in a very actionable way to bring some sustainable solution will definitely create an impact. So why not join us in building the sustainable future? So we actually have this AI-powered global building energy rating solution, basically to reduce the carbon emission. And this challenge is on our Challenge.one portal. So together we can actually work to bring in a better sustainable world, I would say. So yeah, any questions or anything?
Thank you, Nikhita. I think that was very insightful, and you've taken us through, all the details, how to do it and what are the parameters for it. And the vision, of course, is very bold. If there are any questions they have, we have the challenge owner right with us. She'll be very happy to answer all the questions that you have. So feel free, whatever questions you have, just ask.
Internship, we can get full-time job, ma'am.
So the internship would be 12 weeks to begin with. So once you have the pilot thing developed and things like that, so there'll be further discussions about that.
Can you explain your expectation to these participants so they know what they should provide to you?
Perfect. Thanks for that question, Riska. So it'll be helpful for them as well. So basically, the idea is I have just put the challenge in a way that, this is what we want. So I want to listen to different perspectives of people. Probably my approach to it might be, not right. And there's a different approach to it as well. So we would expect as part of phase one to see different ideas or different ways of tackling the problem. So that once we have that as part of the internship in the 12 weeks, we can start to, feature, let's say phase one, we would develop this, phase two, we would develop this, that kind of way as an approach to it. And probably at the end of 12 weeks, we might have a pilot kind of tool that is developed, which can be used as a version one to, go ahead and say the BDR assessors that we have this, are you willing to use this for your assessment purposes? Or do you think you would require it in a very different way or things like that? So that would be the ideal goal of having a pilot after the internship. But initially, for now, for the challenge, just looking at the perspectives of how people think this can be tackled and coming up with the better ideas to make it, usable for all the energy assessors.
Thank you. And we have, special thank you to Nikhita for taking out time for this webinar. So thank you, Nikhita, for that once
again. Thank you so much for having me, and thanks everyone for joining.